Hey there, in this video we're giving an introduction to file handling in C++, and this covers the first part of section 5.11 in the Gaddis textbook. So file handling. If we reflect on where we are in the course currently, we're starting to make programs that are larger and they're built to handle larger amounts of data with arrays and things like that, which is great. The only problem is it's starting to get a little bit tedious for us in the testing phase where we, as hypothetical users, have to sit and type in all that data to fill in the arrays to actually test that it works. So what might be nicer at this point is to just use a file in secondary storage, a file being saved on the hard drive or an SSD drive or a USB stick or something like that, and get the program to just load all that data maybe into an array automatically and save us time on the testing cycle. So that might actually make our development go a little bit faster at this point. Perhaps more importantly, any professional real program is going to be doing file handling. So any program that you've ever used that involves an open and a save command, that's actually file handling, saving information to the hard drive or some other type of secondary storage. So saving a Microsoft Word file, saving a game file and loading it back, loading up a movie or a music file into a player, all of that is file handling. Saving our C++ code files from our IDE and then loading that back up again. We should definitely know about how to add file handling to our programs to make them work in that style. So let's see what that entails. So basic idea of a file. A file is a unit of saved data in what we call secondary storage. Again, a hard drive, an SSD drive, a USB stick, could be a tape drive actually, something like that. The point is secondary storage, as we talked about the very first day of class, is something that keeps the data when the power is off. So you can shut off your computing device, turn it back on later, start your program up, and just have it read all the data that you need out of file storage. Now, there's two separate categories of files that we should be careful about. Files can be in what's called text format, which means that it's a bunch of ASCII characters that's human readable. And that covers a lot of file extensions in Windows, like a .txt file, a .csv file, it's comma-separated values file, it's like spreadsheet programs, very common on websites actually. HTML files for websites, all of those are text that you could load up in a standard text editor like Notepad and read it as a human being because it's just a bunch of ASCII characters. Now, the other category is what's called binary files, where the raw binary has been written to the file. It's not intended to be human readable, just a whole bunch of binary numbers, basically. So that's anything else. That would include .jpeg files for images, or any type of image file, .mp3 files for music or whatever you're using, .mov files for movies or things like that. So anything else would be binary files, and that's great and it's very efficient, but it's somewhat more complicated to get into. So for this introductory file handling here in our first semester course, we're just going to focus on the text files at this time. Later on in the book, in chapter 12, that whole chapter is about advanced file handling, and that goes into more depth about both text and binary files. So you can look up in chapter 12 if you want to see the rest of that story. But we're just thinking about text files here. Okay, so as an overview, using a file is going to require 3 steps in your program. You're going to have to open the file, you're going to have to read or write to the file, and then at the end you're going to have to remember to close the file. So keep that in mind. Hopefully that makes sense about how that works, but we'll look at all 3 of these steps here in this video today. Now, before we get into that, let's talk about this. The file handling structure in C++ uses the object-oriented paradigm. Most of our first semester programming course has been about procedural programming, where your data and your functions are separate. Now, object-oriented programming is kind of the highlight of second semester programming that, at least for our students at CUNY Kingsborough, will be coming in a later term. But file handling uses this, so we ought to at least have an initial idea about what object-oriented programming looks like, because we're going to have to do that today, actually. Okay, so object-oriented programming is a paradigm that packages your data and your functions together. Your variables and your functions are actually packaged together in single things called objects. So file handling uses this paradigm, which is why we have to talk about it today. And here is a little graphical illustration that's actually in the Gaddis textbook, chapter 1. They were actually alerting us at the time, object-oriented programming is going to be really, really important, even though it comes many months later. So here's kind of the idea of an object, is it actually has a package of several variables inside it that it's keeping track of. And in addition to that, it also has a number of functions inside it for things that it can do. Now here in this picture, these are called procedures, and we've said before that the word procedure is basically a synonym for functions. So you can think of these as function A and function B. And of course, functions have their own local variables, and then they have their programming statements, and then there's an endpoint, maybe with a return statement or something like that. And here's function B with its local variables and its programming statements and its return statement. So that's the basic idea of an object, is it's packaging a bunch of variables together with a bunch of functions to represent one single thing in the world. And just as a little teaser, like for our file handling process, an object that represents a single file, it's got some variables for where the file is on the hard drive, how big it is, how much you've read into it so far, like how many pages into it you've read, basically. And then it also has some functions to do you got to open the file, you got to read to the file, or write to the file, you got to close the file, and those will all be objects contained in a particular file object from the perspective of C++ programming. Okay, so we'll have to be thinking about that, and when you have an object, here's what it's going to look like when you interface with it. You're going to be writing a lot of statements that look like this: object.function, parentheses to indicate that it's a function. So in object-oriented programming, we have to initially create an object, and that just looks like declaring a variable. But internally, it's got a whole lot more complicated stuff going for us. It actually has a whole bunch of variables inside it, and it's got functions inside it. So it does a lot of work for us very efficiently. Once you've declared that object variable, then we can access the variables and the functions that are inside it with the dot operator. So with this piece of syntax here, you've got some kind of object with a name. You have to name the object and then dot, which is kind of like opening a door and saying, here's what I want to get at inside you, and then name the function that you want to happen. So again, object-oriented programming is going to be the focus of the second semester course, the way that we teach it, the way that a lot of colleges teach it, like our colleges at CUNY have everything set up like this. But again, at this point, we're just using objects. Someone else has made these file objects for us, and we're just learning how to interact with that using this object-oriented syntax. In the second semester course, we'll learn how to make our own objects, which is a whole separate story, but that comes later. Just at the moment, just be ready to be writing object.function a whole lot. Object.function, the name of the object, and then a dot or a period, and then the name of the function that you want that object to perform at a particular time. Okay, so we'll be seeing a whole lot of that. Now, in order to use file handling, the very first thing, I guess I should call this phase 0, probably the very first thing in your main function, is to declare a file object just like a variable. And you got a couple of different options here. There's a variable type called ifstream, and there's a second variable type called ofstream that you can choose to use. So in C++, we think of these things, we think of them using the phrase file stream objects. In C++, file stream objects are declared and linked to the actual files on the physical hard drive for processing. And the idea here is that we're thinking of these things as a stream of bytes, just a stream of data, a stream of bytes coming into our program or flowing out of our program. And by using this concept, you can abstract away a whole lot of details about exactly how does a hard drive work? How does my keyboard work? I mean, there's a lot of details there, but fortunately that just gets taken care of for us. And as high-level programmers in C++, we can just think of it as a stream of bytes coming into our program. And you know what? The interesting thing is that sin and cout, right? Sin is actually a data stream of bytes coming from the keyboard into our program. And cout is actually a data stream of bytes going out of our program over to the console monitor. So fortunately, a lot of our knowledge about how sin and cout work are already about data streams. And all those ideas are just going to transfer over very easily to these file stream objects that are intentionally set up to be very, very similar. Okay, so you now have these two new variable types. They're not ints, they're not chars, they're not floats. Okay, these two new types come into the picture. One is the type ifstream that you could declare, and that stands for an input file stream. That's bytes coming into your program from the hard drive. And the second type here, ofstream, stands for an output file stream. That's bytes flowing out of your program, kind of like cout sort of, out to a file on the hard drive. So there's a third type that's just called fstream for file streams generally, and you can use one of those for both input and output. You can get more advanced, more sophisticated with that. That's one of the things that we'll talk about up in Chapter 12 in the second semester in Advanced File Operations. But for now, to get started with, I think it's perfectly fine to just use these dedicated file stream types. ifstreams for input file streams, data coming into your program, kind of like SYN, sort of, and ofstream, output file streams, data coming out of your program. All of these things are defined in the fstream library, so you do have to pound include fstream, and then you have access to these new data types to handle file streams. Okay, and again, for my students, I often recommend make a little page of notes as you study this and write down the names of these file stream objects and study that. And certainly when we get to our next lab or assignment, you will need to be using that. Okay, so that's what I call phase 0. You have declared a file stream variable to connect to a file on the hard drive. Now, how do you actually use that? Opening a file, right? We said this is stage 1. So opening a file looks like that, right? Object-oriented syntax is what that's looking like. So doing a file open operation links your C++ object, your C++ object variable, to an actual physical file on the physical hard drive. So you're going to write name of your file, whatever you called it when you declared it, name of your file, and then dot open, and then the function's name is open. Takes one single parameter in the parentheses, and that's the name of the file on the hard drive. So the file name is a normal system name. It could be payroll.txt. It could be mydata.txt. It could be a CSV file. It could be budget.dat is an extension that we use a lot for that kind of thing. But again, we're just thinking about text format files here in this introduction. Or it could be a whole path name. So if you know enough about path names in an operating system like Windows, you could identify the file as c:\data\inventory.csv or wherever your file is. Now, a little detail there is that the way escape characters work in C++, you have to put 2 backslashes to make the actual single backslash for a Windows path name. That's a little detail there. I would prefer to kind of avoid that. So maybe we can find a way to not worry about that. Now, a little detail here, right? You have 2 separate types of file stream objects. So you've got the ifstream, where you're opening it in preparation to have a stream of bytes coming into your program. That's one thing. But then the ofstream is intended for a stream of bytes to go out to the hard drive. So be a little bit careful, because whatever file name you just opened, ofstream, actually creates a new file on the hard drive, creates a new one under that name that you just gave it. And if a file already existed with that name, you just deleted it. So be a little bit careful about that. Opening an ofstream object with a name that already exists deletes the original file, and now you have a blank file with that name ready to receive new data. So just make sure you intend to actually do that when you open an ofstream object. Okay, so that's phase 1, right? We've opened the file, now we're ready to do something with it. We're either to read or to write information to or from the file. So what's that going to look like? Let's talk about writing to a file to begin with. Writing to a file looks like this. So hopefully that looks familiar. Hopefully that looks pretty familiar to something that's very, very common that we've done a whole lot in this semester. So you're going to name the file, and then you have that left arrow, as I call it a lot, the left angle brackets, or lesser, I guess you could think of it like that. And on the right-hand side, you've got some kind of data, which could be a string literal, or a number, or a variable, or the result of a calculation, or something like that. And that's the exact same insertion operator that we've always been using with cout. So writing to a file works exactly like writing information to cout. There's literally no difference whatsoever. What that does is it writes one piece of data to the current location in the output file. And again, you could be writing a variable or a string or a number or anything that you do with cout. And furthermore, again, we're writing text information to a file. All the usual I/O manipulation functions over in the I/O manip library, if you remember that from chapter 3, they all work exactly the same way they do with cout. So you can use fixed, set position, set width to align columns in a table nicely. All that stuff from I/O manip, it works exactly like it does with cout. And isn't that great? Isn't that great that the designers of C++ set things up like that? So all of our prior knowledge about cout works exactly the same. It's just you're not sending the information to cout, you're sending it to your file that you opened up in phase 1. Okay, so that's writing data to a file. Now what about the opposite direction? What about reading information from a file into your program? What's that look like? That looks like this. Okay, you can probably guess that, right? So this here, right, that right arrow, that double right angle brackets, that's the same extraction operator that we've been using for sin all the time. Now over here on the left, you do not have sin. You've got the name of your input file stream object. Over here on the right, as usual, you've got to have a variable. No question about that. You've got to have a variable to receive the one piece of information coming out of the file. And that works exactly like the sin object. So all of your practice with the sin object pays off here. Reading from a text data file is exactly the same thing. And just a little reminder about how that works. What that does is it reads one piece of text data up to the next space or tab or enter that we call white space, and then it stops and it leaves all the rest of the stuff still in the file. And then when the next extraction happens, it reads the next token up to the next space, just like it does with sin. So very, very similar to reading information out of the keyboard buffer. It's just you're not getting information from the keyboard this time. You're getting it from a text file on the hard drive. Great. So again, you've got to have a variable on the right expression here to receive data. You can't put a literal there. You can't put end line there. Those are mistakes that I see quite a lot, but just think back to how sin works, and this works exactly the same way. Great. Okay, so you're writing information to a file, you're reading information in from a file. Don't forget, that's the second phase. There's one more phase to go when you're all done. Don't forget to close the file. That looks like this. See, more object-oriented syntax like that. So to close the file, you name your file again, you put down dot, and you name the function close. The parentheses are going to be empty, doesn't take any parameters. You don't have to send any information in on the close. The C++ system has already recorded what file you're talking about and what's happened to it. So all you have to tell it is that I'm done dealing with that file. And what that does a couple things there. Item number one, particularly if you're writing to a file, there might be an intermediary buffer that's taken some of the information and then packaging it up to send to the hard drive in kind of big batches, which makes it run a little bit faster. So calling close flushes the remaining information out of the temporary buffer, actually gets it on the hard drive into the secondary storage. And particularly again, if you're writing to a file, your operating system like Windows is going to put a lock on the file because it can't permit two separate programs to be writing to the same file at once. That just doesn't make any sense, and it's going to you'll have scrambled up nonsense if you try to do that. So if you open up a file for output, Windows or whatever puts a lock on it, and if you forget to close the file, no program will be able to access it anymore, including your own program if you try to run it a second time, at least up until you reboot the system. So don't forget to close your files at the end of your program, and you'll avoid those common mistakes of having your file get locked on you and unusable. Great, so there are our 3 or technically 4 phases, right? Declare the object as either ifstream or ofstream, I guess that's phase 0, and then open the file with the right file name, read or write to the file to do the actual work, and then finally close the file here at the end. And that is what you need to do for introductory file handling. Okay, and here are some examples of that. This is program 515 in the book. This is a program to write data to a file, writing data out from your program to the hard drive. So the very first thing that happens here on line 8 is they're going to have to declare a file stream object of type OF stream, an output file stream for bytes coming out of your program over to the hard drive. So this is a declaration on line 8. The type is OF stream. It's not int or float or char or something like that. It's OF stream. And the name that we've applied to this object is output file, which is a perfectly good name. It really could have been anything, but we like it to be clear and descriptive, so I like that a lot. That's phase 0, I might say. Now here comes phase 1, where we're going to be opening the file. So you write output file, that's the name of the variable here. So output file dot open, that's the name of the function. And inside the parentheses, you're indicating a file name of demo file.txt, presumably meaning demonstration file.txt. So remember, with an OF stream object, when you open it, you've made a new file. You've made a new file. When you run this program, you're going to see demo file.txt pop up, be created on the fly when this program runs. That's what this program does. Okay, so here comes phase 2, is we're going to write 4 names to the file. So line 14, you see output file, left arrow, the name Bach. And obviously these are 4 famous musicians here. So this looks a lot like lines in the past where we'd write cout, left arrow, and some piece of information. But we're not sending the information to the cout data stream. We're sending it to the output file data stream. Other than that, it works exactly the same. So write Bach out to your output file, write Beethoven out, print out Mozart, print out Schubert, right? They're not going to be showing up on the console like they normally do. They're going to be saved permanently in this file on the hard drive. Great. And then finally, here comes the last phase. You got to close the file right before the end of your program. So you write output file dot close, empty parentheses, and that's how you do that. Name the object, dot, name the function, and no parameters here. And then here is one of the very few pieces of cout in this program. This gets printed to the console. We're going to print done so the user knows that the file handling is over. So that's what happens with this program. We should test this. Okay, so we are going to test this program 515 here. Now, as we start dealing with file handling, our projects are going to have more and more files running around. So in order to keep that organized and keep track of all that stuff, I like to make a dedicated single folder for each project. So that's what I've done here. I've made a folder on my desktop. I've labeled this PR515 for what it's worth, and I've copied the PR515 source code file from the code repository that comes with the book into this folder to begin with. So just one single folder, right, that's got this one single file in to begin with, and that's a standard CPP source code file for C++. So kind of position that over here. Keep an eye on that. Open that up in dev C++ as we do. There's that code file right there. Okay, so I will go and compile this. Now hopefully, again, we have these 3 separate buttons here in dev C++. There's compile. After that, you can run it. There's also the combined compile and run button if you know you need to do both. But I'm going to hit the compile button here. And hopefully, you know, like usually I quiz my students on like what new file is about to show up, right? What does compiling do after all? Ever since day 1, we've been doing this. So hopefully you can predict what new file is going to show up in my folder when I hit compile. Here it comes. Okay, so of course, right, it's that exe, it's that executable file. That's the point of compiling. Make an executable file. Take our human readable source code file, this, translate it into machine code that the CPU understands, and then write that out into this PR515 executable file, of course. That's what compiling has always done. Okay, see, now that I have that, now I can actually run it, and we'll see what it does. Okay, again, keep an eye over here on the folder with where the files are. Let's see what happens when I run it. See what happened there? Now, there's the console. Okay, the console here is saying we're now writing data to the file and done. That's not very much stuff. Let me come back over here. See, that's the result of line 11 with the cout statement, right? That wrote out now writing the data to the file. And at the end, line 21 had a cout statement that wrote the done. Those are the only 2 couts in this whole program. So that's what you're seeing there on the console to tell the user what's happening. But the more important and more interesting thing is that it made a new file called demofile.txt over here. That's really the point of this program. And of course, it was line 9 that actually created the file. And then it was lines 14, 15, 16, 17 that hopefully wrote stuff into the file. So to really confirm that this program's working correctly, I need to go look at demofile.txt. So I'll just double click on this. And on Windows, it's going to show up in Notepad. And maybe I can increase the size this a little bit. And you can see, sure enough, those are the names that were written to the file. There's Bach, Beethoven, Mozart, and Schubert. That was the point of this program, to write those names in this file. So I'm going to say that this program is working correctly. It is successfully making an output file and writing information to it, namely these 4 names. Great. And let me just say, now don't forget that, so anytime that you want that particular list of names back, let's say I got rid of it for some reason, you just run your program again, right? Run this program. There it is again. Demofile.txt is back. And the other thing is, you don't even need deb C++ to do that. So don't forget that exe executable files are Windows programs. That's what they mean. So I could just, once I've compiled it, I can ignore deb C++ and just double click on the exe and the program runs. I mean, that's always been the case. I'll do it this way. Double click over here, program runs. Great, there's demofile.txt. And that's what that program does. Neat. Okay, so writing to a file, that certainly works. All right, so that was a program to write data out to a file. Now this is the reverse of the process. This here, program 519 in the book, is a program that reads data in from a file into your program. So, as you can guess, the very first thing it has to do is declare an object of type ifstream, an input file stream. Data's coming into our program. We're going to call this input file. That's a pretty good clear name there. Now, we do, again, for incoming data, you have to have a variable to receive each piece of data. So on line 10, they're going to declare a variable of type string. We're going to call it name, because presumably the file that we're reading from has a bunch of names in it. Maybe like the one that we just wrote out, actually, with a bunch of musicians' names, perhaps. So strings to receive the incoming names. Now here, line 12, they're opening the file up. So they've written input file, again, name of the object, dot open, that's the function you're calling, and the parameter you're sending in here is friends.txt. Now, for an input file you're going to read from, that has to already exist. So I'm pretty sure that if we look at the lecture code from the book, you've got the code file for program 519, and in addition to that, it provides us with this data file, friends.txt, that has to already exist before you run this program. So you print to the console, little update here to our user. Now I'm now reading data from the file. So kind of in batches here, line 15 reads in one single name from the input file into this name variable. So line 15, again, looks a lot like all the times we've ever used syn to bring in one piece of data from the keyboard into a variable, but we're not getting it from syn, we're getting it from this text file on the hard drive that we just opened up. So in comes one piece of information, gets saved in name, and then we'll just print that out using a cout statement. Just print that name out onto the console. And then do it again. So here's input file, bringing the second piece of data into name, very similar to pulling out multiple pieces of information from the keyboard with syn. But here comes the second piece of information in a name, print that out, do it a third time, so presumably this file has to have at least 3 names in it, right? Read up to the next space, save that in name, print it out. I guess we're done with that. And then we close the file. So that's a pretty good initial example of reading information in from a file, not from syn, but again from a text file on the hard drive. And here is program 519. Now again, I've made a dedicated folder for this project, and this project has 2 files in the code repository. So in this new folder on my desktop here, I've put PR519, which is a C++ source code file, and I've also got this data file called friends.txt that comes with it. You definitely need both. You can see on line 12, right, this is trying to open for input a file called friends.txt, so you've got to have that or this program won't work correctly. Let me just open this up to be aware of what's in this file. Okay, so this text file here has 3 names. There's Joe, Chris, and Jerry. Okay, so I know that. Good to know. I usually like to be familiar with what's in my data files as a programmer. I kind of need to know that in advance to know what to expect from my program. So I'm going to compile this. There's another file that's going to show up right now, of course, and that is, there it is, that executable file, of course, pr519.exe. That's the actual machine code program once you compile it. So I'm going to run this and see what my program does. Yeah, of course. So it prints out reading data from the file. That's line 13 after you open it. And then you've read in the Joe and printed that. You've read in Chris and printed their name. And you read in Jerry and print their name. And that's exactly what this program does. So anytime you run this, it opens up that friends.txt in memory and reads out the data and prints to the screen for what it's worth. And don't forget, of course, this looks like it just pops up instantaneously. It looks like one single thing happening, but that is these several separate statements running one after the other. So how about we, run that in the debugger just to kind of be familiar with what's really happening there. So put a breakpoint here, debug this. So the program's running, nothing's been printed yet. Currently have it paused on line 9. And I just want to take a look at that name variable that holds incoming strings. Now to begin with, name has a bunch of random garbage in it, a bunch of random characters that kind of don't make any sense, and that's what appears to be there right now. But as we run this, I'm sure that's going to change. So let's run through this. Great, make the string variable, of course. So this is opening up the input file for input data stream coming in, of course. Line 13 prints that message to the user. We're now reading data from the file is about to happen. Okay, and here comes line 15. Maybe I'll even bring up this text file here just to remind us what's in there. Of course, now I have a lot of stuff on screen. That's fine. Okay, so just kind of reminding us what's in that file there. So here comes line 15, which reads in the first piece of information up to the new line, which is Joe, and that got into the name variable. Okay, and then line 16 is about to happen. We're going to print out this, the Joe, to the screen. There we go. And now line 18, so the file object knows we've already read this. That's over with. So when we run line 18 here, what comes out of the input file into our variable will, of course, be Chris. There we are. So you see now name is holding Chris, of course. And at this point, this part of the file has already been read. Okay, we're done with that. But the program is going to run line 19 and print out, in this case, Chris, of course. Okay, one more extraction here. So now you read the next thing out of the file, which is Jerry. That goes in the name variable. And you print that to the screen. And at that point, you've read everything in the file. Of course, there's nothing left. You could potentially, in the next video, we'll see how to handle more data than that. But that's a pretty good example of what's happening when you're reading information from a file. And of course, we're wrapping up here. We're returning out of this function, and the program is over. There we go. Cool. Okay, so I think that's a pretty good place to start with. That's the basic stuff you need to know about fundamental file handling in C++, is making a file stream object of either type ifstream or ofstream, whatever you need. Phase 1, opening it up, naming a file on the hard drive system. Phase 2, reading or writing, right, which just looks like sin or cout. No difference at all. How nice is that? And then finally closing the file at the end, so you remove the lock and you flush the keyboard buffer and things like that. So my students and I will get together to practice this for a first time. There's this lab 5.5 that practices both reading and writing to a file. You actually do both here, which is nice. So there's a code file called billfile.cpp. Now, as I do this, again, I'm going to want to keep things in a dedicated folder to keep track of the multiple files that are running around now. So I'll make one folder. I'll bring in billfile.cpp. I'll also bring in this transaction.dat file that's part of the lab, so 2 starting files now. And I think what that has, again, it's just a flat text file, and it has, I think, just like one number for a quantity of objects being bought in a store, and a second number for the price of each of the objects. I think that's actually it. Very, very simple. So you need to fill in code to read in the item price and the quantity from the file, compute how much the total purchase is. That's not very hard. And then you have to output that total bill to another text file that you create on the fly when this program runs. So you get to practice both the reading operation and also the writing operation for your output. So we'll need to test the program with the data file, and what I always need to highlight to my students, and this is new, okay, so again, we never want to get frozen with how things have worked before. We're learning something new here, is I have to emphasize that, note, this program has no console I/O. There's no SYN. There's no cout. There's nothing that gets printed to the console. So when this program runs and you get that black window that shows up, nothing gets printed to it. That's intentional. All of the input and all of the output is coming from text files on the hard drive. So in particular, the output here is in a text file named bill.out. So when you test this program to confirm whether it's working, you've got to open up bill.out in Notepad or some other text editor and see what's in it after the program runs. So just kind of keep that in mind. Again, a pretty good, simple starting lab for file handling. So if you do have access to this, I think it's a good idea to practice this. But don't forget, when it runs, intentionally, nothing's printed to the console. You've got to open up bill.out to see what get printed. That's what this program is doing. So a good starting point. Now, there's a lot more details, right? These are actually very simple little examples we're looking at in our first video on file handling. So when we come back next time, we'll add to the story with more things you can do for file processing. Like, what if your file is really huge? Our examples today were only reading or writing like 3 or 4 things. What if your file has 100 things or 10,000 things? It's very, very easy for your program to handle that automatically, so we ought to see how to do that. And we ought to look at like error handling. What if the file that you're trying to open is missing? What if it's not there? What if the user asks for a file that doesn't exist? We need to be able to keep track of that, detect whether that's happened, and handle those errors appropriately. So we'll be adding a lot more information. Maybe really the next video is what our file handling programs really ought to look like as we get started with this first semester. So hopefully you'll be able to join me for that, and I'll see you then.